Hi, this is Dr. Pandishwari, Assistant Professor in the Department of Civil Engineering from SRM Madurai College for Engineering and Technology. Today's session is on standard conventions in engineering drawing. First of all, what is engineering drawing? It is a universal language used by engineers, designers, and manufacturers to communicate the design intent, specifications, and requirement. To ensure the clarity and consistency, standard conventions are followed in engineering drawing. So, by understanding these standards, it helps the engineers to convey their idea effectively and avoid potential misunderstandings. What is the importance of clarity in engineering drawing? Actually, the clarity it is a crucial for effective communication. It also ensures that all stakeholders can interpret the drawing accurately, and clear representation reduces the chances of error during manufacturing and assembly. Ultimately, this saves a lot of time and resources. Precision in measurement. Precision is a fundamental aspect of engineering drawing. Actually, the accurate measurements are the vital for the functionality of the design component. We engineers must adhere to specific standards for dimension, tolerances, and scale to achieve the desired level of precision. Actually, the drawing standards includes the are defined by international standards such as International Organization for Standardization, which is also known as ISO, and American Society for Mechanical Engineering, which is also known as ASME. And different types of drawing. This includes there are several types of engineering drawing, which includes orthographic, isometric, and sectional views. These in which each type serves a unique purpose and provides different perspective of the object, which ensures a comprehensive understanding and analysis. Coming into views and projections, first of all, we are going to discuss on orthographic projections. It represents a 3D object in 2D using multiple views such as front view, top view, and side view. And the next comes the first angle projection. It comes under the ISO standard in which the object is placed in the first quadrant and the view is projected onto the plane behind the object. And the next comes the third angle projection, which comes under ASME standard. In this, the object is placed in the third quadrant and the view is projected onto the plane in front of the object. And next is the auxiliary view. This is used to show inclined or oblique surfaces true to size and shape. And lastly, the section view. It reveals the internal features by cutting the object along the plane. For example, full section, half section, or offset section. And next comes the types of lines. Actually, lines in engineering drawing have a specific meaning. For example, solid lines, it indicates the visible edges, while the dashed line represents the hidden edges. Understanding these lines convention is essential for interpreting the drawing accurately and conveying the right information. Coming into line types in convention, first we are going to discuss on the continuous thick line. These are also visible lines which represents the visible edges and outline of the object. Next comes the continuous thin line. It is used for the dimension purpose, extension line, and hatching. Next comes the dashed line, which is also a hidden line. It represents the edges or features that are not visible in the current view. And next comes the chain line. These are also known as center line, which indicates the center of the feature or symmetry. And next is the phantom line. It shows the alternate positions of moving parts and repeated detail. Next comes the break line, used to shorten long objects with a consistent cross section. For example, zigzag or wavy lines. Next comes the symbols and notations. In this, we are going to discuss the standard symbols and notation that are used in the engineering drawing to convey the information concisely. This includes dimensional symbols, tolerance indicators, and material specification. And actually, familiarity with these symbols enhances and aids in effective communication. Next comes the symbols and notation. in which we are going to discuss on the surface finish symbols. It indicates the surface texture or roughness. And next is welding symbols. It specifies the location, type and size of welds. And next is this material symbol. It represents the material in section views. For example, the hatching pattern for metals or concrete and etc. It also used for brick in civil engineering applications. And next comes the thread symbols. It represents the internal and external threads. And next is dimensioning, in which we are going to discuss on units. Dimensions are typically in millimeters as per ISO standards, and or inch. It can be represented by inches for ASME standards. Next comes the dimension line, in which thin continuous lines with arrow headed indicates the measured features. And the next is extension lines, thin lines extending from the object to the dimension line. These are known as extension line, and these are invisible lines. And next comes the leader line. It is used to point to a specific feature, often with notes or attonation. Next comes the tolerances, in which it is used to specify the allowable variation in dimension, for example, plus or minus 0.1 millimeter. And lastly, the geometric dimensioning and tolerancing. These are used to define the allowable variations in form, orientation, and location of the features. Lastly, it is we are going to end the session by discussing on the title block information, in which firstly we are going to indicate the drawing title, in which the name of the part or assembly. And next is a drawing number, in which we are going to give any unified unique identifier for the drawing. Next comes the revision number. If it is necessary, we give revision number because it indicates the version of the drawing. And next comes the scale, the ratio of the drawing to the actual size. And next the materials, it specifies the material to be used. And next comes the approval signature. It indicates the approval of the relevant authorities. And finally, we would like to conclude the video by adhering to standard convention in engineering drawing is vital for achieving the clarity and precision. By understanding and implementing these standards, engineers can improve the communication and reduce the errors and enhance the overall project efficiency. Thanks for watching.